Welcome to the first part of the KROSET webinar organized by Kawasaki Robotics located in Wixom, Michigan. In the next 45 minutes, we will give you an overview of KROSET, introducing the simulation environment, and by the end of this webinar, you will be familiarized with the software and able to create a simple project. The agenda for today is to give you a general overview and basic concepts about KROSET features and specifications. Secondly, show you the software environment, including the menu bar, settings and options offered by KROSET in offline simulation. Then build a simple project, which will be further used in the next parts of our webinar. And finally, I will show you some common functions and concepts used in KROSET for the project development. KROSET is an offline programming application designed for creation of teaching programs and simulation of Kawasaki robots. It is relatively simple, clean, powerful robotic simulation package, which includes the actual AS system of Kawasaki robots and provides accurate simulation. The most important feature is that runs the Kawasaki Robot Core software on a PC, providing the true kinematics calculation, motion plan and accurate cycle time in order to eliminate project risks and reduce work time. The software contains many extension plugin functions for various applications. And for the PC requirements, on installing and using KROSET, we need a Windows version XP 7 or 8 operation system. The PC is recommended to have at least 12 GB RAM and a dedicated video card as support for the OpenGL graphics. KROSET is used in modeling, offline programming and simulation. With this software, we are able to create and visualize 3D models of robots, tools and objects from the workspace, as well as devices used in real world. The built-in KGI library has the full line of Kawasaki robots and many sample work objects such as pedestals, safety fences, or we can import 3D CAD models in the STL format. Also, we can generate simple shape models using the Simple Shape Generator plugin. About this plugin, I will cover in detail later in this webinar. For now, the key thing to remember about it is that it is useful for quick demonstrations and layout verification. An example of layout is given here, where we have a palletizing robot with a bag gripper. It is great if we have a cat model available for the bag. Otherwise, we can use a rectangle box obtained by the Simple Shape Generator, which will represent a bag well enough for a simulation. Further, KROSET is, as we already specified, an offline programming environment which allows us to edit step-by-step programs for the robot, as well as test them using a virtual teach pendant equipped with auxiliary functions. We can also use the simulation plugin included in the software. With KROSET, we can use the AS language as well as block step programming, and we have available an intuitive mouse click teaching and drag and drop functionality to quickly create motion programs. These mentioned features will be shown soon in a KROSET demonstration. And last but not least, using KROSET, we can simulate and check our applications. The simulation function animates the robot trajectory and calculates the cycle time. Unlike other software, KROSET provides features such as collision check and layout verification. During the simulation of the project, we can record with the entire robot motion in the area view, as well as obtain screen capture images. For more advanced applications, we can simulate complex systems with multiple robots and input-output signal communication which synchronize them. An example is given here, where we have 6 robots placed around the car body completing tasks such as welding or painting. Here are given some examples of plugins that KRosette provides to its users. We can analyze the location where the robot was installed. We can generate simple shapes such as cylinders or boxes, or exchange virtual signal input-output, touch sensing for arc welding, virtual conveyor and actuator movement, setup wizard for external axis. We can estimate the power consumptions. Also, we have a plugin designed for specialized teaching panel for paint, specialized parameter settings for spot weld, or a tool called KSpark used for palletizing tasks. KRosette supports Kawasaki's full line of robot models from B series to Y series, used in different applications such as handling, palletizing, painting, or welding. Also, based on the application type, we have available different controllers, starting with the D Plus controllers and including the latest E-Series controller version. Next, we will continue with the second part of our webinar, and let's start to get familiar with the KRosette environment. Please open the KRosette software. Now I would like to talk about the KRosette environment, introduce different panels and tabs, show the mouse and keyboard operation, and talk about the KRosette screen, namely the menu bar, the view control bar, plugin settings, and option settings. If we take a look at the screen, we have a blue area, which this area represents the view or the virtual environment, which is a screen where can be displayed a model in 3 dimensions. In addition, in this area, a viewpoint can be changed and the model can be dragged to move. On the left side of the virtual area, we have 2 pages, the start page and the layout page. In the first page, we can create a project, we can open a stored project, or we can edit a project with Quick Builder. Also, we have recently used projects and samples of projects from handling application, from welding or sealing. These examples from different applications are useful to practice examples with KRosette. On the right part of the virtual area, we have a task panel containing different tabs. For example, program, input-output signal connections, under location, paint, create painting programs, or we have the teach panel. In the teach panel, we can create teach points, set up the home position of the robot, or jog the robot, but these things we will see later. And finally, under the virtual area, we have another tab or other tabs such as input-output monitor, controller, terminal, and paint. In the controller tab, we have quick settings where we can activate different options such as enable collision detection, show colliding planes, stop the robot when collision is detected, or follow the TrackLine file by selecting the output TrackLine file. In the terminal, we can run or type commands or debug errors. Here, because we do not have an open project, we cannot type commands. This area is inactive, but when we have a project on work, we can see the functionality of this tab. Some other tabs can be activated in this region from the plugins menu, from settings or plugins. For a better understanding how the view operation with mouse is working, now we will open a simple project. Let's pick the RS010 floor handling. Double click on the project and the work cell will be placed on the center of the virtual environment. If we want to rotate the image, in order to see much better the work environment with all components, we just need to press the right click on the mouse and start to move the mouse till we will find a good angle to visualize the work cell or the corner of the work cell we are interested in. For a zoom view, we need to press the Control key and the right button on the mouse to drag a view. Now you can see how the image is zooming, or you can just use the mouse wheel and you can zoom in, zoom out the view. For a pan action, we can press the Shift key and then press the right button of the mouse and we can drag the view. So now you can place your robot to the right, left, up or down. And again, for a view rotation, please uh, press the right button of the mouse and move the mouse. Now you can rotate your virtual area. More functions can be found on top of the view area in this toolbar. And let's see few buttons that we have here. For example, we have the previous or the next buttons, which helps us to change the view angle. So if we press this button, you could see that the work cell was rotated, or we press the next button and again the image was rotated. We have a fit button which helps us to display the model in the view perpendicular to a visual line. For example, in the XY plane, YZ plane, or ZX plane. So if we click on the first option, XY plane, now you could see that the image was placed perpendicular to the XY plane. We return back to the initial, almost the initial position, just to visualize the work cell. And what we can do in the toolbar, we can save the virtual area, the work cell, as an image by pressing this button, Save as Image. So now the only thing what you need to do is you need to give a name to your picture and save into a location, for example, the desktop and so on. Or we have another button which is important. We can display our virtual area by a single view, double views, or 4 views. We will keep a single view for our project, and let's continue with another important button, which is the click action. By default, this button has selected the option Select Object, and this button helps us to change the behavior of the left mouse button. So let's see what is doing this Select Object. So if we press an item in the virtual area, it will be highlighted by green. So as you could see. Then we can change the tool by using the Adjust View option. So when you click a surface, you will change the angle of that work environment. So let's click. So you could see that the angle was changed. Or we can change to centering, and you can center to the click location. Okay. Okay. There are some more options in the menu bar, such as View, Settings, Help, Plugins. From the first option, View, we can select to visualize the project axis by Show Axis, which is an origin of the world coordinates displayed with an arrow. So if we rotate the virtual area, here we can see the world coordinates. Or we can visualize by selecting Show Compass. We can visualize the world coordinates direction, whereby the z-axis is represented by the blue color, the y-axis by the green color, and finally the x-axis by the red color. As well as we can show the ruler, which gives us an idea about the robot cell dimensions in the units of millimeters. The second option in the plugin settings let us to bring more plugins, test panels in our project, and we will see plugins like handling, um, handling simulation, installable position analysis, collision check simulation. So we just need to wait a window. Here is the plugins window, and we can see the collision check, the handling clamp, handling simulation, or if we go down, we can see simulation and so on. The third button is the help button, where we can find the manual that we have regarding the KRosette application. And if we check the version information, we will see that we are using 1.6.9 version of KRosette. So here is the Kawasaki Robot Solutions KRosette and the version that I already mentioned. And finally, in the plugins, uh, we can find more functions, plugin functions, and also the option settings panel, where we can change the language. We have different languages. We can display the view highlight, the project file. We can display the collision, show colliding planes or enable collision detection. We can display the style, and if we go in the controller tab, we can save the controller's configuration with project file automatically, or save and recover the controller's memory automatically. This second option is recommended to be activated. And finally, to close the window and save all change that we made, we just need to press the apply button and press the cancel button to close the window. Now that we have an idea how looks the work and works the KRosette environment, we will continue with the third part of our lecture. In the third part of this lecture, we will learn how to create a project using Quick Builder. Please double-click on Edit a project with Quick Builder. The Quick Builder started and we can create our simple project. We need to give a name, so let's pick session 1, and we validate by pressing the OK button. In the start page, you will find the project, session 1, and in the layout, the program environment. Currently, it is an empty project. With Quick Builder, we can add or select to our project different robots, tools, work and obstacle environments, upload step-by-step programs, or select some options, for example, the model interference, the cycle time, or the teach pendant. Now let's continue to build the project following the Quick Builder process and click the next button to continue the application. We need to select a robot for our project, so we click the Add button and the library window is opened. I will minimize just to see what type of robots do we have in the libraries, KGI libraries. So we have the handling robots, arc welding, servo welding gun, painting, sealing robots. We will select a handling robot equipped with an e-controller and a robot from the R series. Now we will look for the product code corresponding to the RS020N. We open, and now you will be able to visualize the robot placed in the virtual area. In the Quick Builder window, we can also do some settings. for example, for the robot. I will open this window. So here we can select the pose for the robot. Currently I use the floor pose, or we can place the robot on ceiling, wall, or change the angle specifications. Or we can change the coordinates of the robot. However, now we will maintain a simple project, so we will not do any changings here in this setting page. We return back to the quick builder and we will continue by pressing the next button. And now for the R01 robot, we need to add a tool. So we press the add button, and because we have a handling robot, we will select from the handling folder a tool which corresponds to the hand tool. On the right side of this window, you can visualize the shape of the tool. And now we press the open button, and in the virtual area you can see that the tool was placed on top of the robot, at the end effector of the robot. Now we continue by pressing the next button, and we need to add some work and obstacle environments. The difference between a work and obstacle is that the workpiece will have a certain action in the project. Meanwhile, the obstacle will be a fixed environment, such as fences, conveyors, pedestals. Generally, the products and what the robot manipulates will be considered a work environment. Now, for the workpiece, we will press the Add button. We will keep the given name, Work1, which was automatically generated by KROZ. We press the OK button, and now we will select from the Simple Shapes folder a box, and let's pick box S. We open, and the box was added in the workspace. And now we continue by adding an obstacle. Again, we will maintain the same name, obstacle 1. We validate the OK button, and now we need to bring a pedestal in our project. So we need to find it in the equipment folder, and here we have pedestals, and we pick this one. We press the open button, and now you can see in the virtual area that you have the pedestal. We continue the project. At this step, program, we can upload PG files, but because we want to keep a simple project, we will continue the project by pressing the next button. For the option step, we can keep the option selected by default, or we can check what we have included in the option section. So if we open this page, we can select the model interference, so highlight the interfered model. We can select the display, the grid line, select between the large, medium, and small size of the teach pendant, select the cycle time, display the screen when simulation stops, or we have the program table where can be highlight the executing step. Okay, we return back to the quick builder window, and we continue by press the next button. And to finish the project, we need to press this button. The quick builder example was created. In the virtual area, you can visualize a robot, a pedestal, a tool, and in the layout page, we have the program architecture, so the robot, the tool, the obstacle 1, and work 1. The project can be found in the start page in the recently used project session 1. And we will go back in the layout page. And as you can see, work 1 piece cannot be seen in the virtual area. What we need to do is we need to change its coordinates. But I need to mention that in KROZ we have 4 types of coordinates named converted coordinates. The coordinate values consist of 6 values, which are 3 values indicating the position of the robot and 3 values indicating the orientation, and are generally expressed as x, y, z, OAT, and the converted coordinate values are classified into 4 variations: world, local, tool, and base coordinates. The world coordinate system corresponds with the world origin and is an absolute coordinate system. The local coordinates have the origin at the local xy plane. The tool coordinates correspond with the tool origin of the robot. And finally, the base coordinate system is located at the origin of the base coordinates. In the layout page, as I mentioned, we have the project hierarchy. We have the robot, the hand tool, work 1, and obstacle 1 environments. For changing the work 1 coordinates, we need to go and double click on work 1, and we will change the x and y coordinates with 500 for the x-axis and for the y-axis with 1000, and we will keep 0 for the other coordinates. We select to be the base coordinate world. We apply, and now we press the OK button. Now you can see that the box was moved away from the robot, and also you can see that the robot is interfering with the pedestal. What we need to do is place the robot on top of the pedestal, so we need to go to R01 robot, double click and change its coordinates. So we will raise the robot, so we will change the z-axis with 765 or 745. We apply and we validate OK. Now you can see that the robot was placed on the top of the pedestal. For the changes we've made in the project, it is imperative to save the project. For this, we will go on Session 1, right mouse click, follow project, and save. We save and we overriding the file. Now that we have a project, let's try to use some plugins. For example, we will create a box using the Simple Shape Generator. For this, we need to go in Plugins tab and select the Simple Shape Generator function. And you can see that here we have different shapes: box, prism, pyramid, cylinder, and so on. We will pick some dimensions for our box, so let's pick 300 for the x-axis, 300 for the y-axis, and 600 for the z-axis. And here we have the option to select that our environment will be a work, item, or an obstacle. So now we select work. The box was added in the virtual area, and in order to visualize the box, we need to change its coordinates. As you can see, we have an work 1 environment, which is the box, and the second box inserted using the Simple Shape Generator plugin was renamed as work 2. And now we will change its coordinates. So let's pick 1000 for the x-axis and 1000 for the y-axis. We apply and we press the OK button. Now you can see that the second box is placed near work 1. If we do not need an item in the virtual area, we can delete it. So we can go in the layout page, right mouse click on work to. So we will delete the second box and we follow the option delete. We validate our choice and now you can see that there is no work to piece neither in the layout page, neither in the virtual area. I will retake a short discussion about the task panel containing the controller tab. So we go in the controller tab. This information will be useful in the next part of the webinar. So in the controller tab, we have quick settings as well as you can see, an operation panel. And the R01 corresponds to the robot, C01 corresponds to the controller that we have. As you can see here, we have several buttons such as repeat, motor, cycle, error, reset, emergency. The first button is a switch that changes the mode to teach or repeat action. The second button turns on/off the motor of the robot. The third button is the cycle start, and the lamp is lighted up when simulating in state of repeat mode. The error button lights when errors occurs, and the reset button turns off the error. However, if errors continue to occur, then the error cannot be released. And finally, the emergency button intercepts the motor power and stops the robot when it is pressed in an emergency. We have few more buttons like show monitor, which is a status monitor to display the values of the robot joints, or synchronize button, which helps to synchronize the parameters between the PCAS and the layout, or we can display the teach pendant by pressing the show pendant, and then we have the option hide pendant to close the teach pendant. This button represents the execute button and run the program. This load helps us to load PG programs, which are transported to the virtual robot controller, the PCAS, and more information will be given during the webinar when we build and run programs. In this third part of the webinar, we learn how to create a simple project, select environments from the KGI libraries, use the simple shape generator, save a project, and see the controller tab functionalities. Now we can continue with the last part of lecture 1, and let's learn more of KROSET, common functions, and more concepts. We continue to work on the same project named Session 1. This time we will take a look at the tree panel from the layout page, where I will give you some information about the physical and logical items. Then I will point out the parent-child relationship existing in the tree panel and distinguish the difference between the items in the virtual area. Besides this, we will learn how to teach points in the virtual area, and few more common functions will be presented. If we briefly summarize Session 1, we have the following items. A robot RS020N with the corresponding coordinates already set, the end effector of the robot equipped with the hand tool. The robot is placed on a pedestal and we have a work item near the robot. All enumerated items are placed in the tree panel located in the layout page. Some of them are physical or logical items. The difference between them is that the physical items exist and the logical items doesn't have a real form. The robot, the tool, the base, the joints, the workpiece and obstacle are physical items. Meanwhile, the flange, the logical joints, the teaching point are logical items. About the parenting relationship, we can drag and drop objects in the tree panel and create the parenting relationship. In order to show you an example, we need to add another workpiece. We will not use the Simple Shape Generator plugin. We can copy work 1 item and paste it. So, in order to do this operation, we need to go on work 1, select and right-click mouse, follow Edit and Copy option. Then we need to go on session 1, right-click, select Edit and paste. As you can see, in the project architecture, we have two work environments, work 1 and work 2. Work 2 has the same coordinates as work 1, so we need to change work 2 coordinates, double click, and now let's pick for the x-axis 1000. We apply and we press the OK button. Now you can see that work 2 was placed near work 1. Now let's define work 2 to be the child of parent 1. So we need to drag and drop work 2 to the work 1 item. So click on work 2, drag and drop on work 1. Now if we follow the program architecture, work 1 became the parent of the child work 2. The effect of this motion is the following. So if we need to move many items, it is the easiest way to place the work items representing children attached to their parent, then start to move the items. So, if you want to change the coordinates of work 1, work 2 will move with his parent. Double click on work 1 and let's change the x-axis with 750. And now you will see how both elements will move. So we apply and work 2 followed his parent. Now, if we want to save this change, we will press the OK button. If we want to return to the initial position, we will give 500 on the x-axis. We apply and then we press the OK button. Next, we want to learn teach points. So please go in the layout page, right-click mouse on the project, and then select Add, then Point, and Assign Position. The teach point is the coordinate serving as reference of the tool end when the robot is operated. So for a teach point, TP1, we need to change its coordinates, like let's pick 500 for the x-axis, 1000 for the y-axis. We apply and we validate OK. Now the teach point was placed at the base of work 1. We can show origin, and now you can visualize much better the teach point. You will see that if we will change the coordinates on the z-axis, for example, if you pick 100, you will raise the teach point on top of work 1. Now we can change the name of the teach point, so just right click on TP1, select Node, then select Comment. We will name this teach point as target. We apply. Now you are able to see that the point that was placed at the base of work 1 has the name as target 1 in the virtual area. In the layout page, we will change the name again, like target. And now you can see that both in the layout page and in the virtual area, we have the same name. Because we checked the teach point target or TP1, the robot jumped to that point, but we can continue our lecture. there is no problem. It's what happens when we test our teach points. If there is an inconvenient teach point, we can delete, or if we want to move the robot, we will learn in the next lecture that we can jog the robot from the teach panel. One more thing that we need to know about KROZ. So first of all, always do not forget to save all new tasks included in your project. And secondly, record the position of all your items included in the project. The reason of recording all positions of your items is that once you will run your application based on a step-by-step program, you will not be able to turn back the items to their initial positions. The only solution you will have then is to reset manually each item position if you remember the given coordinates. More than that, when you select the work and obstacle environments, only the work items will be moved in your project. So you need to right-click mouse on session 1, right-click mouse, select batch operation, then position, and record all, or you can record only the robot or the environment. We will record all. Now your items are saved, and if you want to bring the items to the initial position after you run the program, you need to go back in session 1, select batch operation, position, restore, all. About this function, we will talk later in our webinar lectures when we will create more advanced projects. Summarizing our first webinar lecture, today we learn about the KROZ environment, how to manipulate the view area and layouts, how to create a simple project and use the KGI libraries. We learn how to use a plugin for creating a simple shape, distinguish between the KROZ existing coordinates, teach points, save or restore their position. Later in our next lecture, we will learn how to jog a robot, write a step-by-step basic program for moving the robot arm, run a program, and record the simulation movie. Thank you for your attention, and please follow the next lectures of our KROZ webinar. And do not forget, if you have questions, feel free to send us a feedback at the indicated email address.